In this video, we're going to be studying piecewise functions. These are functions that are made from other functions. The function itself will change depending on where you look on the x-axis. Here's some examples. In this graph, you've got three parts. You've got the blue, purple, and green part. This function is made up of three different functions. I'm going to put boxes around these functions. So you've got the blue box, the purple box, and the green box. If we want to represent this as one big function, we write f of x equals, and then we open this curly bracket where we're going to list all the other little functions. So f of x, our function, is equal to the three smaller functions, the blue one, the purple one, and the green one. But it's not enough to just write those rules. You also need to tell us where those functions start and stop, for what values of x. Because the purple function only works in the purple zone, not in the blue or green. So you need to tell me where that is on the x-axis. Starting with the blue function, f of x equals x minus 1, this happens everywhere on the left side of the graph. So x here is allowed to be less than or equal to 0. Moving on to the purple graph, here we have to stay between 0 and 2. So x has to be less than 2 but greater than 0. And finally, the green graph happens anywhere to the right of 2. So here, x can be greater than 2. Let's see an example of a question you might see on a final exam. Charlie decides to go for a bike ride. Function f described below represents the distance between Charlie's house and the relation to time elapsed from the start of his bike ride. So we're given a graph, and under the graph we see f of x is equal to curly bracket, and there's four parts to this. That means this graph is made up of four smaller graphs. During the bike ride, Charlie passes a statue at two different times. This statue is located 4,550 meters from his house. How many minutes elapsed between the two times that Charlie passed the statue? Let's break this graph up into its four pieces by drawing boxes around each piece. Now I've got the blue box, the purple box, the green box, and the red box. These are the four functions that make up this piecewise function. In orange, I've also marked extra information which shows where the functions start and stop. The blue function is between 0 and 20, so it stops at 20. The purple is between 20 and 24, so it stops at 24. The green is between 24 and 28, so I stop at 28. And the red is between 28 and 56. There is one more piece of information we'd like to know, and that is at the top left corner of the blue box, how high is that? And I want to know how high that is because on the y-axis I'm measuring distance. And the statue is said to be 4,550 meters away from the house. Is that between the blue dot and the topmost measurement of 5,600, or is it underneath this blue dot? To know this, I need to know where that blue dot is. This blue dot is the maximum value of the first function, which means I will need to find the value of f of x when x is at the last possible point, 20. So f of x equals 250x, and we want to know what is this equal to when x is equal to 20. Doing some algebra, we can work backwards to find that f of x is equal to 5,000 meters. So when I say that the statue is located 4,550 meters from the house, that's below this blue point. This is important to know because when I draw a horizontal line going through 4,550 meters, we see that this horizontal line in orange crosses the blue part of the graph and the red part of the graph. Those 2 points are what we're interested in. We will need to use the first part of the function, which is 250x, and the last piece of the function, which is minus 200x plus 11,200. Those are the two pieces of our piecewise function that we need to use. To find the time that he crosses for the first time he crosses the statue, we're going to use the first piece of the graph. And so working backwards, we need to find the value of x when y is equal to 4,550. Working backwards, we get x is equal to 18.2 minutes, which means that 18.2 minutes is the first time he sees that statue. The second time he sees the statue happens in the red part. Using minus 200x plus 1100 2000, we can work backwards again to find the second time he crosses the statue. We use our algebra and work backwards to find that x is equal to 33.25 minutes. Now we have the two times when he sees the statue. The first time is 18.2 and the second time is 33.25. To find the distance between these two times, or to find how much time has elapsed between these two times, we're going to do the difference between these two times. And what we do is the big number minus the small number. 33.25 minus 18.2 is 15 minutes 0.05. 15.05 minutes.